Hey guys, welcome. We're going to do just two problems today, and so take your time, watch them, watch what I'm doing, and we're going to use elimination and substitution, and we're going to look at some special cases. We kind of briefly mentioned these cases before, but we're going to go ahead and take a look at them in a little bit more detail. Okay? So two problems. We'll start with our first problem here. We have 2x plus 8y equals 6. And we have negative 5x minus 20y equals negative 15. Okay, and we usually put this little bracket here. It means it's in the system. They kind of correspond to one another. And my goal is to find x and y. Okay, I'm going to choose to do elimination in this method. So this will be elimination. I'm just going to mark it with an E. So I need to eliminate something. Right now I see a 2 and a 5. I can't eliminate those by addition or subtraction. I see an 8 and a 20, and I can't eliminate those either. So I'm going to have to get kind of creative here and think about what I can multiply. What I see is the 2 and the 5 are smaller numbers than 8 and 20, so I'm thinking that might be a better option to go with. So I'm actually going to try and figure out what two numbers will 2 and 5 both fit into, and I think the smallest number is going to be 10. If I multiply this equation by a positive 5, I'll get 10x. If I multiply this equation by a positive 2, I should also get 10x, but in this case as a negative. So let's go ahead and write our new equations, and I'm going to go like that. 5 times that is 10x, so I'm just distributing here. 5 times 8 is going to give me 40y. And 5 times 6 is going to give me 30. We're going to do the same thing here. This time I'm going to go ahead and do it with this one. So I'm going to distribute the 2 over here, so I get negative 10x. This is going to become negative 40y equals negative 30. Okay, so my goal is to eliminate here. So I'm going to, they're opposite signs, so if I add them, they'll eliminate. And let's get my red out here. Let's do red marker. So 10, negative 10, that's going to cancel. So that's what I want. I want to get rid of one variable. I have 2. I need to get rid of 1, so I have 1 left over so I can solve it. Here's the interesting part, though. 40y minus 40y, that also cancels. And 30 minus 30, that also cancels. Basically, what I'm left with is 0 on this side, and I'm left with 0 on this side. Is it true that 0 equals 0? Yes. Okay. This is true. So yes, that's an E. Yes, this is true. What does that mean? Well, it means they're the same exact line. Our answer becomes infinite, let's see if I can write, infinite solutions. Okay, another way you'll see me write this is using the infinity sign. Infinite solutions. It means if I were to graph some sort of line, the other line, the second equation, is the exact same line. So that means every point on the line that goes on forever is a solution. So how many solutions are there? Infinite. It doesn't mean everything is a solution. It just means there's an infinitely many of them. Okay? Let's go ahead and take a look at our next problem. Okay, problem 2. We got negative 3x plus 3y, that's a y, that's ugly y, equals 4. Having trouble with my pen right now. And then we got y equals x plus 3. Okay. Now, we're not going to do elimination. This time we're going to do substitution. And what I can tell from this is I have this piece right here, and I'm going to substitute it in right there. The reason why I'm doing that is because I know y equals x plus 3. So instead of the first equation writing a 3y, I'm going to write 3 and then plug in x plus 3. Okay? So I'm going to rewrite the equation, negative 3x plus 3. But I'm going to go over and put parentheses. then finish it out, equals 4. So I'm substituting instead of y, I'm substituting what y will equal, and that's going to be x plus 3, because it says right there. We'll distribute, so we get negative 3x plus 3x plus 9 equals 4. Okay, negative 3x plus 3x is going to be 0, so those cancel, and we get 9 equals 4. Is that true? Does 9 equal 4? No, not true. So we say no solutions. Okay, and graphically, what does that look like? It means we could have one graph going like this, and the other graph is going like this, parallel. Those are supposed to be parallel, and they will never meet. So where do these two lines meet? Well, they don't meet. So our answer is no solution. Those are two special cases. Normally we get our normal cases where we get one answer, an x value and a y value, and that's where they two lines meet. It would look like something like this. Where they have no solution, we could be like kind of parallel lines, okay? Or where they have infinitely many solutions, they're the exact same line, and they share every single point. All right, guys, that is all, and we'll see you later.